Hello, and another question, exam questions of course, exam questions answered, and test questions answered, on vectors, A-level further maths, and more on vectors. With respect to a fixed origin O, the lines L1 and L2 are given by the equations, well, the first line, r is equal to, and the second line, L2, r is equal to, respectively, where lambda and mu are scalar parameters. Show that L1 and L2 meet and find the position vector of their point of intersection A. B. Find to the nearest 0.1 degree the acute angle between L1 and L2. The point B has position vector 5 minus 1, 3. C. Show that B lies on L1. And D. Find the shortest distance from B to the line L2, giving your answer to 3 sig fig. And this is a question, exam question, for 14 marks. 14 marks. We'll have a go at that. We like that. So, without further ado, let's do the maths. So, how are we going to start this? Well, this goes back to our first port of call where we use r is equal to a plus lambda b, and it tells us that. So L1, and oops, it's a bit too thick again. I'm always getting the thickness wrong here, but it's real time. So let's make sure that's sorted out. Okay, yep, and let's move this over here. All right, so let's just get rid of that and let's start afresh. And we don't want to take up too much time because this is a big question for 14 marks. Excitable. 14 marks. So L1, r is equal to a plus lambda b. R is equal to a plus lambda b, and r is equal to, well, it tells us 3 minus 2 and 4, and plus lambda and 2, 1 and minus 1. 2, 1 and minus 1. Now, and then I've got L2, of course, which he also tells us is r is equal to, and we got 1, 12, and 8. I'm writing it out so that you can see the procedures when I evaluate, plus mu and 1 minus 2, 1 minus 2, and minus 1. So, and what does that give us? Well, that gives us 3 plus 2 lambda. So this gives us 3 plus 2 lambda, and minus 2 plus lambda, minus 2 plus lambda, and 4 minus lambda. And we're going to put that equal to, again, the sum of what we have for L2, which is 1 plus mu, which is 1 plus mu, and 12 minus 2 mu, 12 minus 2 mu, and 8 minus mu. So, because if the lines meet, they must be equal to one another. So, what happens now is that I'm going to use the I and J. It doesn't really matter, you can use what you like to solve simultaneously. Use I and J, components, I'm just saying what I'm doing, components, to solve simultaneously. So excuse the writing, simultaneously. Yeah. So once we do that, then I can say, well, here's my I. So I've got 3 plus 2 lambda is equal to 1 plus mu. And then I've got minus 2 plus lambda. Got minus 2 plus lambda is equal to 12 minus 2 mu. 12 minus 2 mu. And that's nice because if I multiply equation 2, so this is 1 and this is 2, say multiply equation 2 by 2, so my new equation 1 will give me 3 plus, so this is my equation 1, 3 plus 2 lambda is 1 plus mu, and my equation 2 is now minus 4 plus 2 lambda, which is equal to 24 minus 4 mu. Minus 4 mu. And of course this is still my equation 1, and this is my new equation 2. Now, solving simultaneously, of course, this gives me 7, because 3, if I'm subtracting 1 minus 2, 3 minus 4, that gives me 7. 2 lambda minus 2 lambda, lambdas have gone, is equal to, and I've got 1 minus 24, which is minus 23, minus 23, and mu minus 4 mu is plus 5 mu. Well, that's nice. That gives me 7 plus 23, which is 30, is equal to 5 mu, which tells me that mu is equal to 6. If I subst the value of mu is equal to 6 in equation, I was writing okay there until that time, it's all real time. In equation 1, I'm going to get, what's that? 3, so 3 plus 2 lambda is equal to 1 plus 6, because it's 1 plus mu. So I get this equal to, and scroll up, this is 7, take away 3, which is 4. So I get 2 lambda is equal to 4, which means that lambda is equal to 2. Now, we need to check for consistency, so I need to check the k component, because I used I and j. Always check the one that you haven't used for consistency. Check k component, so I'm stating what I'm telling the examiner what I'm going to do, component for consistency. And this will tell us if the lines actually meet. Consistency. And well, I'm going to use the k component, which is, let's scroll back just to have a look. The k component was 4 minus lambda is equal to 8 minus mu. So 4 minus lambda, so 4 minus 2 is equal to 8 minus mu, which is 6. So this gives me 2 is equal to 2. Therefore, the lines meet. And I can say where they meet at. I can say, therefore, the lines L1 and L2 meet. And I'm going to find where they meet at. And they meet at, where do they meet? Well, I've got 3, because I'm going back now, and of course I'm going to use 3 plus 2 lambda, minus 2 plus lambda, and 4 minus lambda, and substitute the value of lambda in. So 3 plus 2 lambda is 3 plus 2 times 2, because lambda is equal to 2, and minus 2 plus 2 plus lambda, and 4 minus lambda. And we got 4 minus lambda, which is 2. And what does that give us? Well, that will give us 7, 0, and 2. So they meet. So the point A, which is what it says, therefore I can say A has coordinates 7, 0, and 2. And that's the first part done. Now part B, if we need to go back perhaps to have a look. Let's have a look at part B. What's the requirements of the question? Find to the nearest 0.1 degree the acute angle between L1 and L2 for 3 marks. So let's go on to part B. Or maybe I should use a new page. Yes, I think that's, instead of scrolling down all the time, let's go to a new page. So part B. We've got the points 2, 1, and -1. And this is A. And B, we have 1, -2, 1, -2, and -1. And we're going to use now, using the formula that you were given at perhaps the start of chapter 9, cos theta is equal to A dot B, so you do your dot product, over the modulus of A times the modulus of B. And let's do A dot B. A dot B, which is 2, 1, and -1, and multiplied by 1, -2, and -1. 1, -2, and -1, write it out again, and that will give us our dot product of 2 - 2, 2 - 2, and +1. And +1, which is equal to, that's equal to just 1. There you go. And let's do the modulus of A. The modulus of A is equal to, well, that will give us the square root of 2 squared plus 1 squared, 2 squared plus 1 squared plus -1 all squared, plus -1 all squared, which is equal to the root of 6. Which is equal to the root of 6. And the modulus of B also looks like it's equal to the root of 6. Let's just see. Yeah. Modulus of B, which is 1 squared plus -2 all squared plus -1 all squared plus -1 all squared. And of course, yes, that's 1 plus 4 plus another 1, which is also the root of 6. So, well, I'm conscious about time here, but it is a big question. So, therefore, I can say cos theta is equal to 1/6. Because the root of 6 times the root of 6 is 6, and therefore the inverse cosine of 1/6 is 80.4 degrees to 1 dp. And I put 1 dp. Oh, but I think that's what they asked for, isn't it? In the question, to 1 decimal place. Okay, part C. Part C, you're required to show that, and let's have a look again at part C, just to make sure that we're dealing with the correct question. I've got to move that out of the way. Yep, sorry. Okay, part C, show that B lies on L1. So if B lies on L1, I've got the point A, and it's just for 1 mark. So you shouldn't have to do a lot. I've got point A is 7, 0, and 2, and the point B is 5, and they tell you 5 minus 1 and 3. And if it lies on the line, well, A minus B should give you 2, 1, and -1. So I've got 7, 0, 2 again, minus 5 minus 1 and 3, and of course when I do that, that gives me 2 minus 1 and 2 minus 3 is minus, sorry, 2, 1, I apologize, 2, 1 and minus 1. That's better. 2, 1 and minus 1. And that's when, of course, lambda is equal to 2. So I think for 1 mark, that's enough. Enough said. Part D, finding the shortest distance. Well, if I'm going to find the shortest distance, then I need to perhaps do a little sketch of the vectors, and so let's try and do that. Need a line. Here's line L1. So let's call this L1, and no, that's L2, and L1 will be here. L1 here, and then we need our, yeah, we'll turn that into a right angle. We don't have to have it accurate, but then we need a dotted line because we need to find our distance. So hopefully this will be our dotted line here. Yeah, this is our distance D. Yeah, okay, that's good enough. And because I'm conscious of the time, don't like videos to be excessive in length, and this is going to be because it's a big question. 14 marks. A, B, and we call that D. Now this is the angle that it makes, alpha, we call that, and this is our right angle here. Now, OA, vector OA is equal to 702, and OB is equal to 5 minus 1 and 3. 5 minus 1 and 3. And, well, I want BA, the vector BA, which is going to be equal to OA minus OB. OA minus OB. And that will be equal to 702, well, we know that's equal to, because we've done it before, 2, 1 and minus 1. 2, 1 and minus 1. Because we've already done this. To show that B lied on the same line. So BA, or the modulus of BA, is equal to 2 squared, or the root of 2 squared plus 1 squared, 2 squared plus 1 squared plus minus 1 all squared, which again is the root of 6. We've done that before as well, which is the root of 6. And extending our page, therefore I can say, therefore D, the distance, must be equal to the root of 6 multiplied by the angle that we previously found. But we take the sine of the angle, the sine of 80.4. The sine of 80.4, because we know that, let's just make sure that everything is okay. We know that the shortest distance of B to the line L2 is given by D is equal to the modulus of BA times the sine of alpha. Yeah, the modulus of BA times the sine of alpha, times the sine of alpha, and that's equal to d. So that will give us then, what's the root of 6 times the sine of 80.4? That gives us 2.42. 2.42. So D is equal to 2.42, because I think they want to 3 sig fig. And that's it for 14 marks.